Hi, so I'm Leslie, and I am here to talk to you about treating your switches just like you do your servers. So who am I? I've been an operations engineer for a couple of major websites you might have heard of. And now I decided to join Cumulus Networks as a customer engineer, really focusing on automation. So not everyone here has heard of Cumulus Networks. We produce Cumulus Linux, which is a Debian-based operating system for network switches. The whole philosophy is that you should be able to manage your switch just like you do your server. You want to be able to use all of your existing Linux tools, like Puppet, to configure your switches. And so we're currently based on Debian Wheezy. So basically, if something works on Debian, it'll probably work on us, which I think is great. We run on a large number of white box switches. You can see here, it's just the very beginning, between 1 and 40 gigs. We have 5 different vendors: Agama, Dell, EdgeCore, Penguin, and Quanta. Now, here's the real meat of the presentation that I know you all here have come here for. So how many of you have had to manage traditional network gear? Raise your hands. Yeah, right? So I'm sure this is not going to come as a surprise. Traditional network gear managing, I think, sucks, right? You get your new switch. It's got old software. So you have to telnet or serial into the box, because a lot of times it doesn't even have SSH enabled. Then you TFTP a new image over, you enable SSH, and sometimes with passwords, some of these you can't even put an SSH key on. It's like, hello, it's 2014. You have to copy and paste your configuration. And then if you're doing it over serial, I'm sure all of you have experienced at one time where you filled up the serial buffer and then like half your configuration doesn't actually paste in and you wonder why nothing's working. Yeah. And then, I don't know, how many of you guys have tried to automate with traditional network gear? A lot less. It can be pretty hard, right? Like, you've got like these Perl scripts, these horrible screen scraping scripts, just to try to make up for the fact that there's not a lot of APIs and openness, and it's not easy. So, comparatively, also, how many of you have dealt with installing servers, right? Like, that's a lot easier because we've made it better, right? Usually, you get your server, you reboot it, Pixie picks up. Your boot image goes over TFTP, then your boot image pulls over whatever other image or packages you need, either web server or TFTP. Then your pre and post installation scripts also run. You know, a lot of people use Kickstart for scripts, and then your automation software like Puppet will manage your configuration and your administration. So really, like compared to this is great. This is easy. This is lazy. I always say the best sysadmins are lazy sysadmins because we want to make all the computers do the work for us. So since it didn't exist in network switches, we created Oni. Oni is basically like BIOS and Pixie on steroids, right? We used BusyBox, which is a very tiny Linux distribution, in order to create this. And then we donated the source code and the management to the Open Compute project. We felt this was very important because we don't think that one company should rule over an open source project, right? It belongs to the community, and letting software and information be free is very important. So the Oni process looks pretty much like your normal servers process, right? First, it boots up into Oni, and then your switch will go through a discovery process. First, it will look for a USB stick that's plugged into the front. If that doesn't happen, it looks on its management interface for DHCP via v4. Then it will look for IPv6 neighbors, and then it will try to TFTP from a well-known a static IP address. Then search for the proper file name. An Oni file basically just has a little shell script in front of a binary blob. All of this is documented online at oni.org. And then the best part is after that installation process runs, we use zero-touch provisioning. When the management interface uses DHCP, it will request option 239. And then this option will return back a custom provisioning script. Then the Cumulus Linux box will send back these headers. So if you want, you can use these HTTP headers in order to make some sort of automated system to change provisioning scripts if you want to have provisioning scripts not be the same. Or you can just have one static provisioning script as well. These scripts, they must contain this Cumulus auto provisioning flag. It just tells the box, hey, this is the script that you do want to run, just extra level of safety. And it will run as root in any of these languages, which I figure piece of the big four, right? Everyone here probably knows at least one of them. And here's an example script showing just basic setting up and starting Puppet. So if you look here, your normal, hey, look, this is bash on line 1, just trapping errors because when something fails, you want to know why it failed, right? We're just changing a repo line here, upgrading the box, and installing Puppet, our favorite configuration management system. And then we're just making sure Puppet will run at boot, restarting Puppet. You see on line 21 is the auto provisioning flag, and then it exits with code 0, which, as we all know, says this program ran successfully. Any questions about this so far? All right, good. So we want to look. Now installing your switch basically looks just like installing your server, right? You've got the actual hardware, BIOS and Pixie. Same thing is bootloader and Oni. Your server OS, most people use Linux for their servers. We just have network OS, Cumulus Linux. And then the app, like Puppet, and we run Puppet. So there you go. Your switch is now just like your server. And I wanted to show you a video here of Oni boot and ZTP install process. I did a set-x on the bash script so that we can see what's going on. This video will run for about 3 minutes, but I have sped it up. In reality, it takes about 10 minutes. This specific run took about 10 minutes. But I figured we didn't want to all sit here for 10 minutes, and we've all seen servers boot before. So you'll notice here is when I reboot the box. You see, look, here's the bootloader. Oops. Oh, my goodness, that was, sorry. I meant to do the laser pointer. All right, start over again. Normal bootloader. It will then boot into Oni. See, Open Network Install Environment shows which platform this is. This specific box was a Quanta LB9. One of, I don't even know, how many do we have? Like 20 different network switches that we support, growing every day. You can see here, it's looking for Oni. It grabbed a DHCP address and starting service discovery, discovered its installer, verifying image checksum, your basic installation, right? Now it's just dumping over the image via TFTP. You can see here, this is a list of all of the architectures that this specific image supports. It's just a normal header for Oni, normal control file header. It is copying the image into slot 1. One thing that is different about us versus most servers is that most servers don't actually have 2 copies of the operating system on them. They just have 1. But network switches have traditionally had 2, a primary and a backup, because they tend to be a bit more of a single point of failure in your hardware. You usually have your rack attached to 1 network switch, not to multiple. So in case an upgrade goes RE, you can just roll back to the other slot. You'll see, there we go. The installation's done. Obviously, I sped that up a little. Rebooting now. Since the installation is completed, the discovery process will not happen again. It sets a flag because you don't want your switch to be stuck in an ever booting loop of reinstalling. I'm sure everyone's accidentally set their BIOS at one point or another to constantly Pixie boot, and then it's a horrible loop. All right, and here is Cumulus Linux starting. And you will see right there is that nice little shell script that I showed you before, apt-get updating, because when you first install a switch, you probably want to make sure you have all the latest packages. I'm sure did everyone here see about the latest bash vulnerability today? So yeah, if not, after my talk, you may want to go and do a little apt-get upgrade on your own. Here we go, installing all the latest, and this is now installing all of the Puppet packages we need. And in setting up all the Puppet packages we need, and then it will warn us, hey, configuring Puppet to make sure it starts. I did a service Puppet stop here just so I could, in the next video, show you the Puppet run, and exited error code 0. Now that this is exited error code 0, this auto-provisioning script will not run again unless you set it to run again, because we don't want any time the box reboots the auto-provisioning script to always run, right? Like, it's supposed to be a just startup script. So since the switch is Debian-based, we can do everything you need to do configuration-wise via Puppet, right? We can set up users and user account permissions. You can just use sudo. You can just use sudo to give different people different permissions, just like you would with your servers. Right? You can do interface configuration. We use if up down because we're Debian-based. And you can configure your routing software. We usually use Quagga. In this demonstration, I'll use Quagga. But you can also use Bird, ExaBGP, PyBGP, or you can write your own software if you have a lot of time on your hands. And I'll show you a video of a Puppet run. This video is about 1.5 minutes long, but it also has been sped up because we don't want to be here all day. So if you look here, I just wanted to point out that none of the routing is up because nothing has been configured. So this is showing a brand new switch, brand new Puppet run, starting from scratch. I have auto signing on the master, just to make it nice and easy for everyone. Here it's copying over a lot of files, as Puppet always does. Loading all the facts and factor. You can even write your own custom facts. And here we go, look, change the message of the day. Cool, right? We installed the license automatically, causing that process to restart. And you're going to see in a minute, we will update all of the network interfaces. Oh, there we go, creating some users, updating syscontrol. Updating Quagga and NTP. PTMD and interfaces. So as you can see here, Quagga OSPF neighbors are up. PTM is automatically checking all of our cabling configuration, and Quagga has installed all of the routes into the routing table, all with no manual work from any of the admins. Because you wouldn't log in and deal with everything on your server manually. Why do it on your switches? So that's pretty cool, but now we want to make your life even better, right? So how many of you have gone to install in a new data center or install a new POP and none of the connectivity is there, right? Nothing's up. No one? OK, yeah. Come on. I mean, they said that the link was going to be there, but it's not. That always happens. So we can make the switch into a Puppet master. So then you can bootstrap all of your configuration. And so as soon as you actually get that link back to your main data center that has all of your infrastructure, you are ready to go. However, switches are specialized pieces of hardware. They are specialized for switching, right? So the control plane processor and control plane hard drive are limited. So you don't want to do this for the long term. But this is great for, like I said, you have to bring up a new POP. Here is just the example I'm going to use. I just connected 2 switches together and made switch number 1 into the Puppet master. I'm going to show you a nice video using split screen tmux, where you can see on the left here is leaf 1, the Puppet master. On the right here is leaf 2, the switch requesting all the files. I'm just tailing var log puppet master http.log. Wanted to show you that, no, really, this switch is now your puppet master. It's great, and I'm just running the same manifest that I was for the previous example. So there you go. You have a switch as a puppet master. So, yeah, nice. Just made your life easier. Cool. Now, but that's still using existing tools to make our lives easier, right? We have a Debian Linux box basically here. Why are we just sticking to existing tools? We want to make your life even better. There's one problem with existing network interface managers on Linux. They're made for servers, right? And servers and hypervisors. A lot of times you're expecting no more than 4 interfaces, right? Maybe 1 or 2 VLANs, not a lot. So the complexity, especially with IF up down, the complexity of your configuration files can really scales linearly with the complexity of your interfaces. So, and also, you as the user need to know what's going on. You need to know if you want to have a couple of VLANs in a bridge port that maybe has a bond. You need to know the ordering of all of that. It's very important, or else it just doesn't work. And when it doesn't work, you find it out when your box reboots or when you've done service networking restart. And that is not the best time to discover these things. And there's also a lack of support for incremental changes to the network interfaces. Imagine you have a switch, 52 interfaces. You want to add a VLAN to an interface using IF up down. Well, you don't want to restart networking and take down all of your interfaces and bring them all back up. I think all of the users of all those boxes would be a little upset at you. And you can't query and validate that your running interface configurations are correct. But switches are a little different than a normal server, right? There's a lot of interfaces. We've got ports, we usually might have bonds, we might have a lot of VLANs. Each interface may have a lot of attributes, right? We might have spanning tree, we might have MTU, you might have a couple of IPs. It's also mostly static. You usually aren't using DHCP on your switches. So IF up down, the normal Debian Debian network manager we all know and sometimes love, right? Everyone knows it. It's been around forever. But it has all of these same problems that I described before. So we rewrote IF up down in Python, IF up down 2. It's backwards compatible with the interfaces file, so you don't have to all of a sudden rewrite your interfaces file in order to make it work. It continues to use existing Linux native tools. We didn't, rewrite any weird, strange hooks. You can put a large number of interface attributes in very easily. We also have extra Python modules to plug in, so all of your programs you can write software to easily affect your interfaces. And my favorite piece here is IF reload acts like hup instead of restart. So I always use the example, and usually, let's say you're doing Apache, you want to do a service Apache reload instead of a service Apache restart when you add a new website, because you don't want everything to go down and up. You only want what you changed to actually go down and up. So this means that only the interfaces that you've changed will go down and up. Very important when you want to make sure that your switch stays up and happy. Also, IF up down 2 does work on Debian, Wheezy, and Ubuntu. It is not only a switch product. So if you want to try this out and you don't have a switch, you can spin up a Vagrant instance with Debian or something. It's great. So let's compare the CLI. Here's just a single port configuration in IF up down. Right? You have, we want to set this manually to 1 gig. We want to put it in a VLAN. So it's for 1 port, this is a pretty long amount of interface configuration. Imagine times 52. I'd have to have the rest of my slide deck just being that. IF up down 2, tiny, because IF up down 2 knows about the idea of inheritances. So here, is it understands dependencies. Here it says, oh, bridge port 100. Well, I need to see, all right, it has these two. It has these two switch ports. These two switch ports that are actually sub-interfaces belong to these interfaces, has a bond. The bond has these interfaces. So it knows, so you don't have to, which is great. Yeah, and also it has a command. You can create .dot files of your topology, which then GraphViz and many other open source tools take .dot files and make them into nice, beautiful graphs like this. Also, computers are great at iteration, right? So we use the Mako templating language so that you can use what computers are good at in iteration, right? Let's say you want to have your first couple of interfaces be the same. So it's just 1 through 3. It's very important to remember that when you're doing a iteration. But so there you go. Look, done. Let's say you want to have some classes of interfaces, right? Maybe you want to have your interface defaults, and then you want to have like a web server class, because maybe half your ports are all the same, and you don't want to have to retype all of the information again. You can just apply these. You can just apply basically templates, and there you go. Done. Now your config file is even smaller. Less work also means less room for typos and errors, right? If all you have to do is say, this is a web server port, it's easy. If you have to remember exactly what attributes a web server port has, it leaves room for human error. So the best part, I always say code or it didn't happen. Find out more, right? IF up down 2 on GitHub. PTM, which I showed you a little bit of before, it basically uses LLDP to determine whether or not your cabling is accurate, also on GitHub. All of the Puppet code that I used on GitHub, see a little pattern here? All of our open source contributions you can find at oss.cumulusnetworks.com, and you can tweet at me. So now this is our question and answer time. Any questions? Here, oh, I think we have someone with a microphone so that everyone at home.
Sorry.
Yeah.
We're on. Who had the hand up here? Just in front of me? Who had the hand up? Yep, there you go.
Thank you. Great presentation.
Thank you.
2 quick questions. 1, does the box support UDEV, and does it work with that? And 2, will future versions use systemd and potentially network CTL stuff when that hits Debian?
So systemd, it's actually at DebConf in July. So and actually talked about the new network things. So we talked with them about the new network control. They actually hadn't thought of the fact that they may need to have a lot of interfaces. So that is something that one of our awesome engineers, Rupa, is continuing to talk with them. It's something we always, we will continue to look at to make sure, we have whatever the best solution is that we support. And we do want to try to stay very close to Debian mainline. We don't want to, reinvent the wheel because there's so many people using it. So yeah. Oh, and then what was the first one?
Is UDEV used on the box?
Is UDEV used on the box?
It's a horrible thing to talk about, so you don't have to answer.
I can get back to you later. You can find me, actually, our booth is if you walk out the store, it's just in the corner, so find me later.
Thank you.
So I have a question about the use of Quagga and whether you can have multiple routing tables or routing instances or virtual routing functions in your current distribution.
Yeah, so have you heard of network namespaces? It's a Linux thing. So you can use network namespaces. We have a script that by default will help to separate management versus non-management network namespaces. So yeah, so you can try that out because management versus production is the most commonly requested feature.
But if I wanted to instantiate, say, 4 routers that shared no information at all, and then each had a collection of ports assigned to it, is that something that the base system supports?
Not today, but very soon.
Yeah, so the answer was not today, but soon. It is something we're working on with network namespaces.
Thank you.
Any more
So
questions?
that is, oh, well, also, you two had very good questions. And I meant to say before, good questions, well, we have 2 rocket turtles. So good questions retorted with rocket turtles. Whee! Oh, no, oh, I'm sorry. I'm not, there goes my baseball career. All right, and rocket turtle 2. Oh, closer. All right.
I was
Yes.
actually going to ask about System D2. But my other question is, so the Quagga configuration that you threw out with Puppet, I guess I kind of have 2 questions about that.
Yeah.
One is, did you write your own Quagga module? Are you modeling it with Puppet resources, like defined types, or is it kind of just templated?
So I'm using templating. In my spare time, I've been sort of fiddling around with a Quagga module.
Yeah.
Because there aren't really any all the existing Quagga modules I've found have been mostly just templates existing for other people's specific environments. So I've been playing around.
Yeah, we're right there with you.
So yeah.
Which one were you fiddling with Alessandro's?
I don't remember.
Okay.
I've played around with them. It was
And then my other
while
question
ago.
is that like the nature of BGP is such that, and generally in networks sometimes too, but the idea is that you're supposed to back off after a connection has failed or something. So you could it feels to me like Puppet, did you make it aware of that? Or does Puppet just keep trying to connect and it'll just kind of churn for a while?
well, so Puppet doesn't try to connect the BGP neighbors, so Quagga does.
Right, but
So-
I mean, Puppet should probably identify that the Quagga service is in a degraded state and bounce it.
I haven't tried having Puppet, do that sort of a intense monitoring of Quagga.
Okay.
I've been using it mostly for setup, but that sounds like something
Well, it's
awesome
not a good
to play
idea,
with.
so if you're not doing it, that's probably good.
Yeah.
Okay.
Probably got time. One more question down the front here.
Thank you. I just couldn't help noticing, without the license file, what will the switch do or not do?
Without the license file, good question. The license file is required for the first time for switchd, which is basically it's like our firmware driver. To start, switchd actually takes all of the routing tables and pushes them down to the ASIC. So without the license file, switchd will not start for the first time. After the license expires, it will give you warning nags, a lot of warning nags, but it will not disable switchd.
Great. Well, I think we'll wrap it up there. Thank you very much, Leslie. Great
Thanks.
presentation.